Hey y'all, my name is Shri and today I'll be teaching you some physics. Let's cover the basic kinematic vocabulary. Firstly, we have magnitude. What is magnitude? It's basically an amount of something, a value. No need to complicate it for now. Now in physics, we have two words to classify a quantity. Those are scalars and vectors. Scalar quantities essentially just have magnitude. But vector quantities have magnitude but also direction. Maybe you've heard about vectors before, but you can't remember. Okay, now let's move on to examples. Which below is a scalar or a vector? Speed, mass, volume, time, velocity, weight, friction. Speed is a scalar quantity. Mass is a scalar quantity. Volume and time are also scalar quantities. All these have one thing in common. They just represent a value, nothing more, nothing less. Velocity, weight, and friction are all vector quantities. Velocity has direction, depending on the context. Weight is mostly pointed downward due to gravity, mass times gravity. You don't need to know that formula right now, but it's just there. Friction is always parallel to the surface of its contact. All these have direction associated with its quantity or magnitude. Next, we'll move on to distance versus displacement. Distance is a scalar quantity where you could see the magnitude of how far one went, regardless of direction. Displacement is the final position of an object minus the starting point, which provides the net change in position and is associated with distance. We've already talked about speed and velocity. Now you'll learn how to calculate it. It's simple. Distance over time equals speed, and displacement over time equals velocity. Why? Because velocity is a vector quantity due to the displacement showing direction. Here's a diagram to compare the two. This shows an object going from one point and back. The total sum of the distance divided by time equals 4. The displacement is 0, thus velocity is 0, as we've used the beginning frame of reference versus the last. There is no change. But if you were to stop both cars from them returning, the speed would be 2 while velocity would also be 2. They are the same since there is no change in direction yet. Remember in the problem earlier I specified which way would be plus or minus, but it could be swapped if you wanted to. The general rule is up and right are plus, while down and left are minus, but it's not a concrete rule, so it can change based on your context. Instantaneous speed versus average speed. In the diagram showed earlier, the car may have gone faster or slower than 2 meters per second at different points in the trip. Similarly, it's like average speed, but to be more specific, to find a more exact speed in a certain period of time. In this case, 2 to 3 seconds, the car went 5 meters far. So the instantaneous speed is 5 meters per second, which is much faster than the average speed seen earlier.